All right, we're up to section 7.8. And do some problems in 7.8 now. So we're here, pretty much done with 7.7, 7.8, aiming for our next exam again on Friday, 24th. And you're responsible for everything here. Okay, and you can have one cheat sheet on the test as the first test and front and back, and you can have a calculator, but nothing else. You must submit at least 70% of the homework, but that's pretty easy to do considering I do a great percentage of the homework. Anyway, okay, so let's go to improper integrals. Working some of the problems. Okay, question number 5. Integral from 3 to infinity. Of 1 over x minus 2 to the 3 halves dx. Okay, so if we integrate from 3 to infinity, we said we're going to integrate from 3 to b, and then take the limit as b approaches infinity. And this is, of course, x minus 2 to the negative 3 halves dx. All right, so I integrate x minus 2 to the negative 1/2 divided by negative 1/2, means multiplied by negative 2. You can take the negative 2 out, property of limits. So negative 2, limit b approaches infinity, 1 over radical x minus 2 from 3 to b. Okay, so now when b gets big, plug in a billion, this becomes practically 0. So it's negative 2, limit b approaches infinity of 0 minus 1, negative 2 times negative 1. So the answer is 2. All right, so we do not get an infinite amount of area, even though we're going infinitely far. Imagine you're integrating from 3 all the way out to infinity. You do not get an infinite amount of area. You're bounded by 2. So we say the integral converges to 2. Talked before about converges. Okay, let me show you a divergent case. You say, how do you know ahead of time? Sometimes you don't until after you integrate. Okay, 11, integral from 0 to infinity of x squared over radical 1 plus x cubed dx. I know it's a derivative of this is almost this. Okay, so take the limit as b approaches infinity of the integral from 0 to b. So that's what it means to have the limit involving infinity in improper integral. And u equals 1 plus x cubed, du equals 3x squared dx, u substitution. The original did not have a 3, so I put in a 3 inside and a 1/3 outside. I can take the 1/3 all the way out. Change the limits of integration. When x is 0, plug in 0, u is equal to 1. When x is b, u is 1 plus b cubed. So my new integral is going to go kind of weird. It's going to go from 1 to 1 plus b cubed, right? So I is 1/3, limit b approaches infinity. I forgot to put the limit b approaches infinity at first, so it should be right there. Integral from 1 to 1 plus b cubed du over radical u, which means u to the negative 1/2 du. That stays the same. That stays the same. All right, so 1/3. Integral is u to the 1/2 divided by 1/2, which means times 2. Limit b approaches infinity. Take the 2 out. The 2 can join to 1/3. 2/3. Limit b approaches infinity. U to the 1/2 means radical u from 1 to 1 plus b cubed. Plug in 1 plus b cubed. 2/3 limit b approaches infinity, radical 1 plus b cubed, minus plug in 1, square root of 1 is 1. Okay, and this approaches infinity. If I plug in a super big number, this is big. Take away 1, it's still big. 2/3 of big is big. So the limit approaches infinity. So this integral diverges. We get an infinite amount of area. You get all the area that you wish in this case. All right, now 7. What happens if I have a negative infinity? So the picture's like this. Negative infinity to 0. So here's 0. You go infinitely far to the left. So same idea. We put a b somewhere, integrate from b to 0, and take the limit as b approaches negative infinity. Okay? It's pretty much the mirror image of what you had on the other side. Imagine, take this picture and put a mirror there. It kind of looks the same thing if you go on the other side. All right, so what happens when you have a negative infinity? This time, take the limit as b approaches negative infinity of the integral from b to 0 of 1 over 3 minus 4x dx. All right, so limit b approaches negative infinity of, this is your ln, absolute value of 3 minus 4x. And then if I were to differentiate, I'd multiply by negative 4. Since I'm integrating, multiply by negative 1/4. Take the negative 1/4 out. Negative 1/4, limit b approaches infinity. Okay, so plug in 0, I get ln absolute value of 3 is 3. And plug in b, ln absolute value of 3 minus 4b. Okay, and then let's see. When b gets big negative, negative a billion, this is a big number. ln 3 minus that is a big negative. So big negative times negative 1/4, a big positive. So the answer is infinity. You get an infinite amount of area in this particular case. Okay, and what happens if you have a negative infinity and a positive infinity? Okay, well, we now know how to go from negative infinity to 0 and to go from 0 to infinity. So I add the two. Okay, side note, the graph very roughly looks something like this. Goes through the origin. It's an odd function. F of negative x is the opposite of f of x. Okay, and when x gets big, we get an asymptote here, and it goes like this. Okay, so your first impression might be, oh, the answer is automatically 0 because this exactly cancels this. But that's not really going to be true because maybe neither of these is defined. Okay, I will grant you I'm only going to have two possible answers, either 0 or limit does not exist, or the integral diverges. Okay, if this does not exist, get an infinite area, then we're going to say this series diverges. If this is any real number, by symmetry, this is the opposite of that, so the answer is going to be 0. So I'll break it up into I1 and I2. This is I1, it's going to be negative. This is I2, it's going to be positive. They're going to exactly balance. So let's take the integral from 0 to infinity of x e to negative x squared dx. So by definition, it's a limit as b approaches infinity of the integral from 0 to b of the same stuff. Okay, what's the derivative of negative x squared? Negative 2x. There's the x. I need a negative 2 inside, negative half outside, which comes all the way out. Then do my u substitution. U equals negative x squared. Du is negative 2x dx. So negative 2x dx is going to be my du. E to the negative x squared becomes e to the u. And I change the limits. If x is 0, plug in here, u is 0. If I plug in x is b, u is negative b squared. So my integral is negative 1/2, limit b approaching infinity of the integral from 0 to negative b squared of e to the u du. And I decided to flip this. Flip these two and make that a positive. So positive 1/2, limit b approaching infinity, negative b squared to 0, e to the u du. Integral of e to the u is itself. So 1/2 limit b approaching infinity of e to the u from negative b squared to 0. Okay, plug in 0, you get e to the 0, which is 1. Plug in negative b squared minus e to the negative b squared. And now what happens when b gets really, really big? Plug in a million, a billion, a trillion. E to the negative trillion squared is approximately 0. So you have 1/2 times 1, which is 1/2. So the answer is 1/2. So this is a finite area 1/2. And then by symmetry, this is negative 1/2. So therefore, the final answer is 0. So by symmetry, I1 is negative 1/2. So I is I1 plus I2, negative 1/2 plus 1/2 is equal to 0. Okay. All right, then I have here 27 star. This looks like it's from a different edition. Why is this improper? So right now, improper integrals, I might have infinity, I might have negative infinity, I might have both of them. What's so improper about this one? Integral from 0 to 1. Well, you're not allowed to plug in 0, right? I'm allowed to plug in a number slightly bigger than 0. The graph crudely looks like this. Okay, 0 to 1. When you plug in 1, you get 3. If I plug in 0.0001, it gets super big. But I can't plug in 0. So I plug in b real close to 0, figure out that answer, and take the limit as b approaches 0 coming from the right. Okay, so it's a one-sided limit. Right? So if I integrate from b to 1, this integral is well defined. Take the limit as b approaches 0 from the right of 3 over x to the 5th, which is 3x to negative 5 dx. Okay. Limit b approaches 0 from the right. 3x to the minus 4 over minus 4 from b to 1. Take out the negative 3/4. Limit b approaches 0 from the right. X to the negative 4 means 1 over x to the fourth from b to 1. Okay, so negative 3/4, limit b approaches 0 from the right. Okay, so what do you get when you plug in 1? You get 1. When you plug in b, you have b to the fourth. And now what happens when b gets it close to 0, 0.00001? This is a big positive. This is now a big negative. A big negative plus 1. Still a big negative. Big negative times negative 3/4, big positive. So the answer is infinity. So once again, here's an example of a series which diverges. You don't get a real number. All right, then I'll just talk about 31, but I wasn't going to do it. Set you up. Why is this improper? 1 over x to the fourth. I can plug in negative 2. I can plug in 3. I cannot plug in 0. I have to pass through the number 0, right? So negative 2 to 3, I reach an undefined value at 0. Shoots up like that, shoots up like that. But you should know what to do now, right? Here I integrate from negative 2 to b, and then take the limit as b approaches 0 from the left. This one I integrate from b to 3, capital B to 3, and take the limit as b approaches 0 from the right, and add them together. Okay, that's my hint for problem 31. All right. Okay, so this was some improper integrals, and tomorrow, Wednesday, I'll try to do some more improper integrals also. Okay. But otherwise, that's it for today.